Good morning. Happy Wednesday. It's time for some more deep learning in the morning. So I went last time we created this actually learning simple neural networks, and we're going through gradient descent, and I ended up making it accidentally go backwards. Actually, not backwards. It wasn't diverging from the actual like goal. It was just going down. Everything was going down. And so afterwards, I tried it again on my own, not on a stream, and not trying to do it really fast. And it worked, and I was able to get it going. And so obviously that's good. Then last night, after work, I decided to try my hand at the multiple inputs, multiple outputs. I was doing it in Python, and I had the same problem. The prediction for all three outputs were just going down. And so clearly when I put myself under pressure, I make one of the mistakes in the math somewhere. I'm not sure where, that causes everything to go down. So I figured maybe something that will help us out is I want to take all of these functions that we're doing, and before we go on and like fix this and make this right again, is do a little bit of test-driven development here. So I'm going to create a couple files. So first I'm going to create a deep learning functions. And I also want to create a test. I think it's a test, not tests. And then we're going to do a deep learning functions spec.js. So what I'm going to do is install, let's see, that means I also need a package.json. Oh, why do you go in there? Oh no, you didn't go there. And all that has is just an empty object, which means I can now do this. npm install mocha and chai. And that's all we really care about here. All right, those two installed, which means that I can come into our spec. And let's see, what do I need to do? I need const chai equals require chai. I need to set the assert. I think it's something like const assert equals chai dot assert. I think that's it. Miguel, hello. Welcome to the stream after such a long time. It was also awesome been chatting with you on the YouTube comments, so I'm glad you're able to make it. Let's see, and I'm also glad you're able to enjoy your summer. Although, am I remembering correctly? Are you in Germany or Europe? I can't remember where you're living. Netherlands. Is it as hot there as the rest of like France and Germany and everywhere else? Because it's been insanely hot. Yeah, it's great to have you. Great to have you here too. I can never remember if I need the function, if I need to call it as a function, or if I just need the reference to this, like if this is a higher order function or not. I need Chromium. Chai assert. Well, why don't you tell me? Okay. I know I need to get it. Tell me how to get it. Yeah, the temperatures are insane. Yeah, it has been. It's not too crazy here. It's more. It's usually really hot and dry here, and it's hot, but it's not dry. It's a lot more humid than normal, which is crazy. Okay, where? Where's the thing where it shows us what we need? Assure some styles, core plugin concepts. Okay, so you can see like expect equals chai.expect. So it's probably going to be the same thing. Assert equals chai.assert, not calling it because it's just the general object for it. So we just need, that's all we need to do is just grab the reference to the function. Phil, hello, good morning. Yeah, so I took a break due to having a concussion, and that ended up, what was that, 3 months or so, where I couldn't really use the computer or think logically or do much of anything. But I've been able to come back. I'm working again, which is always a good thing, and obviously back to streaming too. All right, so it's just, we're gonna do assert, and let's do a describe. We can do a canary test. All right, so in here, our canary test, we're gonna it 5 should be 5. All right, so assert. I had a viewer that drove you crazy, so you left a little bit. Oh, I'm sorry about that. If something like that happens again, you could send me a private message to let me know who's doing that and what's going on. And I can't promise anything, but at least I'll take a look into it. I definitely don't want to drive people crazy. Let's see. So how assertion styles, assert. Oh, yeah, okay, fine. I don't know why I wasn't able to see this easily. So assert dot and then the thing. Is that it? Oh, right, because this is the guides, whereas before I was just in the API library. So I could just do this and just like check to see if it's equal to that. But I think I can also do assert, yeah, assert like dot equal, assert dot deep equal essentially also, which is what I'm going to be wanting to do. Am I still working with Rust? I want to get back into Rust. I've been doing a lot of different things. Recently, I've been streaming PHP, Laravel, and Vue.js, and that's because the new job that I started a few weeks ago, that's the stack that company is using. And so I wanted to get myself familiar with them. And now I'm working mostly with JavaScript. Well, on stream, I'm working mostly with JavaScript as I learn some deep learning stuff, because I've been invited to the Develop Denver conference to do a live presentation / stream. So if the internet works, I'll be streaming that out. I have 45 minutes, and I want to create an entire neural network, essentially a deep learning neural network, and maybe have it play a game or something like that. And so I've got less than a month now, and I'm gonna learn what I can. So let's do this. Assert dot I think what I can do is just equal, and then we're gonna say 5 and 5, and this should work. And so if I do I have mpx mocha? Yeah, 5 should be 5. If I change this to like 6, it fails. So perfect. And then the other thing that I want to test here is the deep equal. So if we do, I'll just do it in here. So this will be something like the array 1, 2, 3 is equal to the array 1, 2, 3. This should fail. Yeah, this should fail because JavaScript, these are both different values, even though they look the same, and I have to do deep equal. Yeah, it's because it's comparing the references when I just do equal. So I'm gonna take it back. All right. You built an entire new store for the company. They're still using it if you want to see. Awesome. Yeah, I wouldn't mind. Send me a private. Is that even possible on Twitch anymore? To do like, I guess you could whisper me and send it. Or you could tweet at me. Send me a Twitter message. Our company, and I think I can show. It's less of a store because we don't sell things. It's more of a calendar, which it's always a funny thing. I always recommend developers never get into the business of making calendars. It's the hardest thing ever. So yes, we have the hardest problem to deal with, but basically we have a platform where we're allowing doctors to schedule the running of simulations. So physical simulations, or as you're seeing here, virtual reality simulations. Which is very interesting because half the company or half the development team works on a game, but it's not really a game. I do. Oh, awesome. Thank you. I got it. I do want to ask you if, and this is derailing myself from the topic of the stream, but this is a PHP Laravel Vue.js question. I see this everywhere, which is Vue.js used as single page, not single page application, if that makes sense. Whereas each route you load up, it just loads as if it's a new route. It refreshes the page, but then it loads Vue up. So it's a front end framework, but it's not truly single page. And the app that I've inherited essentially is that. Although the CTO wants us to move away from that and go to a more traditional front end framework where we can, with Vue, where we can have a router on the front end and very simple back end, which I am perfectly fine to help move towards. So I'm wondering if that's what you did too, Phil, because I've seen that in a few different places now. All right, so we have our basic asserts. I can just leave that there. If it breaks, then I've done something horribly wrong. And we're going to start importing functions from our deep learning function.js. So I'm going to look through actually learning here. Move this over to the right. And we're going to start recreating these functions over in here so that we can use it to properly do this and then have it be tested, which hopefully should help. So what do we need here? It can be a single page. You have to move to using Vue router. We had PHP load the pages, and Vue was used to build the pages essentially in modules. We use server authentication and not JOTs. You did not use Vue router at all. Okay. Yeah, I think that's sort of how we're doing it right now. And we're going to move away from that a little bit. All right, so neural network. We could start with this vector multiply. So we'll first import it. So const vector multiply equals require. So this is going to be coming from the deep learning functions. I guess I want to, we'll export an object and then we can just pull in what we need through here. You found JOTs to be a little bit unsafe at the time and you'd need that for authentication. How do you win a full SPA? Yeah, JOTs done incorrectly or through local storage can be incredibly insecure. Ironically, when people think they're being more secure. And it's all because people install extensions or advertisements. All right, so we have that. So now we want to describe this. So describe. This is going to be vector multiply. And so what do we want to have happen here? In a vector multiply, and for anybody who's watching again, hasn't watched the previous parts, a vector is a list of things. So it can be something like 1, 2, and 3 is a vector, and it's a vector of size 3. And what's interesting here is in gaming, a vector is a point. So it's would be more like an object that has an X and a Y, and a Z potentially for a 3-dimensional vector, and you can have multiple dimensions. So it's very close to that definition, but not quite exactly. So vector multiply is going to take 2 vectors, hopefully of the same size, and we can test that, and then multiply them against each other. So we could have the first element of the vector equal the second element. So what I'm going to do is going to say, okay, const, well, actually, no, we need the first it. So the vector multiply should multiply 2 vectors together. All right, so what have I heard of VS Codium? No, I don't think I have. So we're going to do with const vector A, and this is going to be, we'll just do 1, 2, and 3, and then we have const vector B is equal to Let's do 4, 5, and 6. And why are you unhappy? Because I misspelled const. Oh, it's a fork of VS Code that has all of Microsoft's telemetry turned off. Oh, almost, but not, like, very similar to Chromium then, I would say, as opposed to Chrome, which is like before Chrome's added all of their API stuff. Although I think they still have some in Chromium, so maybe not exactly the same. I might have to try it. Let's see. Okay, so we have vector B, vector C. Okay, and then we want the const, like the result. So the expected output. The way this is going to work is we're going to take the first element of A and multiply it against the first element of B and create a new vector that it returns that will come here. So that's how I understand that vector multiplication works. So this would be 4, 10, and 18. So now I can assert. So assert that vector multiply, handing it vector A and vector B. Assert dot deep equal is equal to expected output. So that's what we want here. And let's run it. Cannot find module deep learning functions. Well, that's because I haven't added. Actually, cannot find module deep learning functions. Oh, right. I need to go 2 out. So it should find the file. Yeah, there it is. It just doesn't find the function. It works exactly the same. It's for those who are privacy concerned. Okay, I might check it out just to sort of decide if I want to try it or not. So far, I've been happy with VS Code, and I haven't felt like it's too damaging to my privacy. But yeah, I don't know. All right, so it's not a function. So let's fix that. So vector multiply. So function vector multiply. We're going to take in a vector, vector 1 and a vector 2. And we want to, both these are going to be arrays, and we want to multiply them against each other and return that result. These arrays should be of the same size. And I wonder, I could map through this. I think that's what I did in this one over here. I don't see well, I could see a problem with this because it's relying upon this external thing here. I could do a traditional for loop, or I could just map it. So let's try this. We'll return map, vector1 dot map. We're going to get the sort of the first vector. So first number, and we want the index. And we want to return the first number times vector 2 of index. So the same position. And that just returns that. And I want to module.exports equals vector multiply. And now we have passing. So now it's working. I could add functionality for, like, hey, if I don't hand you the right size, so it should fail if 2 vectors of different sizes are passed in. And this would be, let's see, const vector A equals like a 1 const vector B equals 1 and 2. No expected output. We want it to just throw an error, and I think I can actually do that. Assert that a function will throw an error. Message throws and throw are the same thing. One has 2 overloads and one has 3 overloads. All right, we'll just try throw, and then we're going to call vector multiply and pass it in vector A and vector B. Oh, interesting. Expected one to be a function. Assertion error expected, and then this to be, oh, it actually attempted to do it. Do I need to throw? So if I just throw here, so if I just throw new error, blah. Yeah, okay, so that didn't work either. Even though I'm telling it that I want it to throw, it's not exactly what I was intending it to do. I kind of want to look up how the throw works. So function error like string. Okay, so you put in a function, error thrown must have this message. Wait, do I need to pass it a function reference? I kind of wish that these examples were better. Well, yeah, I'm gonna do that if statement in there. I'm just trying to get the throws syntax right first. Come on, choose that. Mimarn, welcome. Good morning. All right, let's head back to Hugh. All right, throw. I guess I could do this. Well, it threw an error, and that had an error when I want it to be maybe throws. No, it's the same problem. Even though I want it to test this, I think it wants just the reference to the function. Okay, this passed. Should fail if 2 vectors the same. Okay. So if I pass in a different message, okay. but will it fail if I do this correctly here? So we're going to do if vector1 dot length is not equal to vector2 dot length, then throw new error, vectors must be same length. Yeah, cannot read property length of undefined. So I wonder, do I need to bind this? So if I say vector multiply dot bind this, I don't really care about this value, and then I need vector A, vector B. To throw error including hello, but got, oh, vectors must be the same length. Okay. Was that what I got before? No, okay, so that is how I do it. I don't really like this syntax, but it's what we have to do. So vectors must be same length. Save that. All right, everything is passing again. So the idea here is I want to rewrite all these functions, and then we can redo the gradient descent algorithm with, what was it? It was a single input, multiple outputs, I think is what we were doing. Because, yeah, input one, multiple weights, multiple outputs. And then we'll see if we got that working. So we can actually start playing with this here. In fact, I kind of wonder if I want to just delete. You know what? I'm going to ignore this file altogether and create a new one. And I'm going to call this a single input, multiple output JS. Okay, so const input equals, let's do 0.5. I'm just sort of making up these numbers. In fact, I guess I could use the numbers that we got from this book. So if you haven't seen other videos, I've been going through and learning using this book called Deep Learning, Grokking Deep Learning. It's I'm gonna save my review for it until I'm done with the book. I've had some things that I like about it and some things that I don't like about it so far. That being said, I've been able to learn using it, so there is that. Where were we? That was multiple that's multiple inputs. I want to do single output. Multiple outputs. So single input, multiple outputs. They're using weights. So I'll just do this. Const weights equals this vector 0.3, 0.2, 0.9. Oh, okay, I see what they're doing. Am I reading the book? Yeah, I can't show the book on screen because this is a full like copyrighted book and everything else. But what I can do is I can't copy paste that either, but I could just happen to reuse the values. All right, so the inputs that they're using here is like a game, like a sports game, and we're predicting if there's a win or a loss. So if we say like a const win loss record, if that's, let's say it's 0.65, And we want to have our input. Oh, our input is just this win-loss record. So I'm just going to name this input there. And then we have they call it true, which I'm not really happy about that. So I'm going to say expected, or like what really happened. It doesn't really help in the context of like numbers that don't mean anything. So I'm going to say expected result, expected prediction. And they have this as like how hurt, whether or not it was a win, and if the players are sad. So we're going to say 0.1. 1, and 0.1. Those are the predictions we want our neural network to make. Okay, so we have our input, we have our true, we have, then we do the prediction, okay, and we're going to get everything else. Okay, so the first thing we would want to do is start getting the prediction. So I'm going to do it without a loop here. We're just going to go one step at a time, and we'll sort of play around with that. So our prediction is going to use a neural network, and we're going to pass in the input and a weights. And clearly we need these functions. So I'll just put these up here. Function neural network, and we're going to take in the input and the weights. All right, so what do we have? We have a single input, and we have these 3 weights, and we want 3 different outputs for this. And what that means to me is that we're going to have to multiply each input by each weight, and that will give us our predictions. That being like that's a super simple neural network, and it kind of works. There's no learning, and there's more stuff that needs to happen clearly, but we're gonna start here. So multiply input by all the weights. This is a scalar value. This is a vector. We need a scalar vector multiplication. So we only have vector multiply, so let's add that function in. All right, what is this? This is scalar vector multiply. It should multiply a vector by a scalar. I don't really like the test where people just say it should work, because that doesn't really give me much feedback when I'm looking at errors later. All right. So okay, let's start. So const our scalar is going to be, let's say, 10, and our const vector is going to be 1, 2, and 3. And const expected output is going to be, so 10 times 1, that's going to be 10, 20, 30. So that's what I'm expecting from here. Obviously, if I get any of this math wrong and you see that and you think that I should change that, I'm going to activate this. It's the Twitch highlighter, so you can use the bang line command to highlight whatever line in the file that I'm currently open as. Which I think is pretty cool. The ability to turn them off apparently is lacking. So like once you highlight it, I don't know if I can necessarily unhighlight it without refreshing this, but we'll figure that out later. All right, so now I can assert deep equal our scalar vector multiply function. We'll pass it the scalar and the vector and the expected output. All right, not defined, not surprising. Let's add this in here. It's still not going to be defined, or not a function anymore. Okay, so back into here. Scalar vector multiply. All right, so we're going to bring in a scalar, a vector. We're just going to map through the vector and multiply it by a scalar. So it's going to be return vector.map. We're going to get each item from the vector, and we're going to return the item times the scalar. And that should be it. All right, passing. So that's working the way we expect it to work. So coming back to our single input, single output, we need to bring that function in. Scalar vector multiply, and then I can just start using this. So we're going to say return scalar vector multiply. We're going to hand in the input and the weights. And with if I was using TypeScript, I can get actual like types from these. So we'll save this, and we have our prediction. I mean, not really all that helpful, but I guess it gives us something. Once we have our prediction, we need to find out what our error is. It's like how far off are we? And to calculate the error, it's simply the difference, the delta between the prediction and our expected prediction. So this is going to be vector, like a scalar vector subtraction, where we're going to say, okay, we need the prediction minus the expected prediction. And I have that correctly, right? It's not the other way around. It is, yeah, prediction minus the expected prediction. And so therefore we need to do that. Scalar prediction. Actually, no, prediction is a vector. Oh, this is going to be just pure vector subtraction then. And we're going to have this one like position 0 minus position 0. All right, that works. So let's create that here. Describe scalar vector subtract. I know that I could do an add and then just like multiply it by -1 to do subtract. I don't really feel like I want to like do that. I'm just gonna create this function that just does subtraction, and that's all I really care about. So it should subtract one vector from the other. All right, const vector 1. Let's make this bigger so we have positive numbers for this test. Well, we can do 10, 20, 30. Vector 2. And we can do 5, 10, 15. Const expected output. All right, so this is going to be this one minus this one. So that would be 5, 10, 15. Assert dot deep equal. We're going to pass it vector 1 and vector 2. And we the expected output is what we expect to get in. Not defined, so let's go create that. So scalar vector subtract. Oh, you're right. You're absolutely right. This is, I don't know why I got like stuck on a scalar when it is vector. So thank you. This is just that. Vector subtract. Yeah, I got the it right. I did everything else right. I just named it wrong. Thank you, Miguel. All right, so vector subtract. Vector subtract. Vector 1, vector 2. This is going to be very simple to our vector multiply. In fact, we can pretty much just copy and paste this in here. We want to throw if this is not the same length. Return vector 1.map. We get the first number in an index, so it's going to be first number minus the second number. And then we'll put this in here. Vector subtract. Oh, right, and I need to pull that in. All right, all passing. Continuing on. So to get our subtract, this is going to give us the delta. So const prediction delta. So this is how much we're off by, is going to be vector subtract the prediction and the expected prediction. Okay, so we have now how far we are off. We need to know how close we are getting. So this would be the error, like how much of an error we have. And what I think is really interesting about this is we're going to do this exact same thing. We're going to subtract the prediction from the expected prediction. Then we're going to multiply it by itself to both get a positive number, and it's a positive number and also a blow. I want to say blow it out of proportion, but I can't think of the right word for like what this is. The only Vic, good morning. You're new in this coding business. Can you explain what is deep learning? So correct me if I'm wrong, everyone else. Deep learning is creating algorithms that use that they're basically creating chances. So like percent chances by using division. To like basically say, okay, I given this input, this is the outputs that we would expect to have happened. And the learning part of it is where we have these weights, and we update the weights until our predictions are correct for a variety of different circumstances. And we could even have this algorithm auto, like, continuously learn, so that way it every time it's wrong, it updates the weights so that it becomes right more often. I haven't gotten to the part in the book where I actually do that in more than one round, which will be interesting. I think that's back propagation, but I could be wrong there too. I haven't actually gotten to it yet. All right, continuing on. We have our prediction delta. We want our error. So if we take a look, error. Because these are deep learning functions, I might as well create an error function for this. So in our spec, calculate error. It should calculate, or should return, side note, you technically cannot subtract a scalar from a vector, although many libraries allow this due to broadcasting. This means that the scalar is broadcasted as a vector. Oh, would that be like, you say like, okay, I have a scalar of like 1, and then you have a vector of 3 items. So it just creates a new vector of 3 items with each one being the same. But yeah, if I read like literally the next 3 or 4 characters, I would have seen that. Just FYI, if anyone would ask something like that during the talk or stream. Ooh, okay, so that's actually really interesting. So I can add, but I can't subtract. Huh. That's fast. I wonder what the history behind that is. Like why that is. Should return the error. Oh, it can't add as well. Okay, well then that's oh, okay. So this is just more of, in the traditional mathematical algorithms, there is no sum if they're not exactly the same data structure. Okay. Should return the errors. Multiplying, dividing is allowed. Okay, so those are just things I need to remember. That is interesting. So technically, I'm doing something illegal here. I don't know. Vector subtract is legal. I'm not doing anything illegal yet. I might in the future. Okay, should return the error vectors. An error is exactly the same thing as the vector subtract, except it's also multiple. Each one is multiplied by itself. So if I have const vector 1 equals, we'll do this exact same thing here. Okay, vector 1 equals, okay, so our expected result is 5, 10, and 15. So 5 squared, so 5 times 5, that's 25. 10 squared, 10 times 10 is 100. 15 squared, this is where 5, 25, 15, 250? Is that right? Actually, I could just do this here. Node 15 times 15. 225. Okay, off. Okay, so assert there. It should. Oh, a vector subtract instead of the correct one. This is going to be calculate error. I guess technically it's calculate errors. And it's going to be pretty much the exact same thing as this vector subtract. And you know what? Now that I think about it, I kind of want to just do this and use vector subtract on its own. So we're going to have vector calculate errors. We're going to take vector 1 and vector 2. And the first thing we're going to do, so const, the delta is going to be vector subtract of vector 1 and vector 2. Once we have that, we can now return delta.map. And so we're going to get each item, so it's going to be a number, and we're just going to return the number times the number itself. I guess I could do the math.pow like I did last time, but this is fine as well. All right, so there's that. Calculate errors. Here. I want to see if the auto import thing works. Calculate error. Oh, it's not. Whoa. Vector 1. Vector 2. All right, all passing. I can use it. Will this work now? No, of course not. We'll bring in calculate errors, and we'll pass in the, what is it? The prediction and the expected prediction. So there is a reason to get the error, although the error is not going to be used in any of the forward calculations from now on. It's the error, from what I understand, is going to be used to determine when to stop training the network, because we're not really getting any closer to the correct prediction. We're very close. And because we're working the floating point numbers, we're probably going to get within like 10 decimal points of what we want to get, and that should be fine. All right. Once we have the prediction delta, the next step is we want to turn these into weighted prediction deltas. So that's going to involve multiplying the input by each of the prediction deltas. Yeah, I think that's what it is, right? That's oh, did I call it? They're calling it weighted deltas, and that's what it is. I think they're also wrong here. This book has it multiplying against the weights, which I can't imagine would then ever change. So we're going to do, I think it's the deltas. So prediction deltas multiplied by the input. So the scalar input. So we need scalar multiplication now. Scalar vector multiply. We already have that. So we're going to do this again. So const weighted delta, or weighted prediction delta, is equal to scalar vector multiply. Our scalar is the input and the prediction delta. Okay, so now we have weighted prediction delta. We can use this to update our weights so that we can guess a little bit closer each time. And this is the one that, I guess, like when I step through it, it does make sense. When I don't think about it, it doesn't make sense. It's one of those things where, like, you have to actually look at the numbers and see it happening and go like, okay, right. That's the reason we want to subtract this. So we want to take these weights and we want to subtract this vector by this vector. But for each of them, we want to multiply it by something known as the alpha. So we'll do this as 0.1 for right now. Or maybe 0.01. I don't know if there's the book says there's no science to choosing this alpha. This is a limiter. So this is going to limit how fast we can move the weights. If any of you watched me do my Lua game making or the Rust game making, I was limiting the frames per second using a very similar method to what we're going to do with this alpha. Katali, hello, good morning. All right, so we have weighted prediction delta. We want to take each of the weights and subtract from the weighted prediction delta, but multiply the weighted prediction delta by the alpha first. I kind of feel that I can do this first and then, because I have subtract, vector subtract. So I have the two things I need. Yes, I am doing gradient descent with multiple outputs. So the only name I can think about this is limited weighted prediction delta. I don't really know better words to use this from. And I assume that as I learn the computer science or more mathematically precise terms, I could start using those instead, and that would limit my variable names. So the first thing is I want to just scalar vector multiply the alpha, which is our scalar, by the weighted prediction delta, which is a vector. You're also reading the book. You tried that yesterday, but you can't make it work. All right, well, we'll see if we can make it work. I did get it. I've been going through and running these in Python, and I was able to get it work there. So, all right, so we got this. That's our limited weighted. So this is now going to be a very small number. Now we want to subtract it from the weights. I kind of feel like just doing this. Let weights. And now we're going to say weights equals. We're just going to fully reassign these weights. And we're going to use the vector subtract, vector 1 and vector 2. And I think it's going to be the weights first, because it's weights minus the limited weighted prediction delta. And that's one step. So this time we can now console.log the prediction. So let's try this. Prediction. Yeah, I'm just gonna go do this right now. And let's run this. So node. All right, so here's our predictions. If we take a look, where we're trying to head is here. And we're starting, so 0.195, trying to get to 0.1, 0.13, trying to get 2 1s. That needs to go up. This needs to go down. And 0.585 needs to go down. So down, up, down. If I, let's do this as a for loop. So not in there, right here. For let count equals 0, count is less than, we'll do 5 steps. Count equals count plus 1. Okay. That went forever. What did I do? How did I screw up the for loop? All right, so let count equals 0. Count is less than 5. I should... JavaScript. Count. Okay, let's try this again. Here's our 5 prediction. Oh man, and you got the highlight work too. That's awesome. Thank you, Kotali. All right, prediction. So we start with 0.95, and we're trying to go to 0.1. So 0.194, 1.941. So look, it is going down. This next one is going up. So 0.13, 0.133. This one's going up. And then the last one, that is going to 0.1, 0.585, 582. So this is going down also. Miguel, yes, so if you're not familiar with JavaScript, the specs for JavaScript does say that you're allowed to create variables willy-nilly, just like this. And that's perfectly legal. It is, however, a very bad idea because it becomes a global. It just becomes a global. And it won't tell you. So that's the reason why so many people use linters. So if I had a linter installed and running, it would yell bloody murder at me and says, don't do that. All right, so that sounds pretty. Yeah, it is. It's sort of like Lua in that way. Lua does the same thing. All right, so this is working. If we now switch this, I'm going to switch this over to a while loop. So you're going to be a while. So this is the one thing I don't like about the highlighter. I can't see the highlights here to turn this one off. So what I have to do is disconnect you and restart it. And now it'll show up again. So I'm going to create another variable called error threshold. I'm set this to 0.0001. I have no idea what a good error threshold for this is. What I'm going to say is, also error is not available out here. So this needs to be that error equals, let's just do like error threshold times 2. And we'll just calculate this error and add it in here like normal. And now I can say, while error is greater than the error threshold. As soon as our error gets smaller than this, so as soon as we get that close to where we want to be, we'll stop looping. So save you. Oh yeah, you're actually correct. Because I'm almost thinking of like the old way is doing it with single output. Error threshold is going to be one thing. I do need to verify if it's each of these things. So you're right, because error is error is going to be a vector, isn't it? All right, let's try this. We're going to just do an infinite loop, and at the bottom here, we're going to have to loop through and then decide if we need to break. So I mean, if I break the other loop, that's not good either. I just need to determine. Can you break out of 2 loops? I don't know if I want to do that. I can do a flag. So I can do something like this. Let should exit equals false. And then I want to loop through the errors. So we're going to do this again. Const error. Error. Error dot for each. No. For each. No, stop. I don't trust you anymore. All right, so I think I'm going to just call this errors. So then I can just do this. Error. If this error is less than, they all need to be. We need them all to be. Oh, that's interesting. Okay, we're gonna do a. This is getting more complicated. That should exit equals. Okay. So new plan here. I just thought of. We're gonna do a const. Still learning equals, and we're going to take the errors and reduce. We're going to get the count still learning, and we're going to get the next error. What I want to do is calculate if the error is below, so I'm just going to go ahead and do this multi-line here. If the error is less than the error threshold, so that means we're ready to stop. We're going to return count still learning plus 1. So increase that number. Otherwise, do nothing and move on. We're going to also start this with a 0. Reduce sums the errors. Reduce is going to run a function for each of these, for each of the errors in the vector, or in the list, I guess. And then I'm going to be able to, whatever I return comes into this reducer here, or the reducee. And at the very end, it's going to return this into still learning. So I'm now going to get a number, 0 through the length of errors. Oh, like for capture the flag? Well, that's not. Please don't advertise that in here. I'm not really interested in those advertisements in these areas. Yeah, that's awesome. And thank you for that. I just don't know if this stream is the appropriate place. Twitter, probably you could share that with me on Twitter. I think would be a better place for this. All right. What was? All right. Now that I have this error count, I can say if the still learning dot length, if that is equal to the expected prediction dot length. So if we have, I think I've named this wrong. Still learning is actually going to be greater than. Oh, so still learning, so 0. If still learning dot length is equal to 0. Then I want to break. Let's see if we can get a not infinite loop. No, we couldn't. Cannot read property. Oh, if still learning is equal to 0. That's all. Oh, it never got within Still learning returns an integer. Yes, I believe it does. So here's our integer. We're not getting within. So it finished training. It's not going to get any closer with the alpha that we have. And we can see our prediction. So we got, what is this? Our expected prediction, we got to 0.1, 0.99, and 0.1. We got very, 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 very close. So I think this number is off. I can actually, where is it? Run the debug, start debugging. Oh, look how slow that is. And I want to watch still learning. I may crash. Hopefully not the computer. It's very unhappy. Not available. Stop. Oh man, my VS Code is now completely, it looks like it's completely frozen. I didn't think that it was gonna, well, I guess I should have thought of that because it's got an infinite loop. And I told it to debug, which meant that it put all the debug hooks in there and then ran an thing with an infinite loop. Which is not the best of ideas. Yep, that's, go ahead and close. Okay, let's, yeah, I know. Let's do this again. I think you may be right. I think it is at the limit of floating point numbers. So here, deep learning functions. No, not functions. This one. So I don't know if our error threshold, like this may need to be more numbers. Or wait, no, it may need to be less numbers. But it may be having trouble with this math and not doing it right. I guess if I console log, actually, you know what? So I can debug this. So I can run the debugger, but I must remember to put a breakpoint in before I start. Let's try this again. Okay. So still learning is 3. So then I step through, that's F10. Oh, just play again, F5. 3, 3. So we want to get until it's like really close. I kind of want to help it cheat. We're starting with 0.65. This is starting like closer to, let's do like a 0.1, 17. Restart. Okay. Actually, you know what? To make it faster, I don't have to play with these. I play with the alpha. Let's make this 0.1. That'll make it 10 times faster. Yeah, look how much faster it's going down now. Okay, so still learning. I want to watch still learning. Oh, it became not a number. That's not good. How did I manage to screw that up? So const still learning, this should reset every loop and start over again with this 0. And then I'm still learning +1. What did I do? So it was around 102. How did that happen? What did I do? The function doesn't return. You're right. You're right. I forgot we need a return. A return or an else. So if the error is greater than the threshold, return count still learning. Otherwise, return count still learning. That's what it is. Got it. I don't want to return 0 because that will reset count still learning. I just want to return whatever this is. Okay, so let's stop the debugging and then just run this. And now it stops the way we want it to. And it stops right when we get to this part, so I can add more zeros. And every time I add zeros, it will make this more correct in its prediction. So eventually I'm going to run up to the floating point limitations and then bad things will happen. But every time I add zeros, we're getting a little bit more accurate. And that's, unfortunately, I ran out of time, so I couldn't get to the multiple input, multiple output. But I think what we did was we made everything gonna go a little bit faster for us because we have this testing library. And I do need, I need a get ignore. Get ignore. Did I put that in test? No, I did. Okay, I did not. We're going to put the node modules. Everything else is fine. So let's go to hue, add you all. Created library with All right, I'm going to push that up, and I've got, for the code that's being sent out, where is that? It's right here. And GitHub. Oh, not that one. That one. All right, I'm going to share this with you. In case you want to go take a look at it, this is the code that we did today. If you want to run these tests, you would need to npm install. So you need to have Node installed, and then you can just do npm test. Otherwise, the file should work. So you just run node space this single input, multiple output file. And if you obviously just want to take a look at the code, there is that option too. So with that being said, I think what we ended up doing here was just being a little bit slower with building the network and using test-driven development, which prevented me from having that problem that I had last time where everything just went down all the time. And now I'll be able to reuse these functions next time when we do multiple input, multiple output. So I'm sorry we weren't able to get to that today. The next time I'm planning on streaming is Fridays. I'm doing these programming before work streams on Monday, Wednesday, Fridays, around 6:45 a.m. Mountain Time. That's before I obviously head off to work. After work, I've been just going through and trying to stay ahead in the book. I'm caught up to where I am right now. Actually, I haven't fully done the multiple input, multiple output exercise yet. So I'm going to get to that, and then this Friday we'll do it. We'll do it live. I don't think I have anything else. So if you enjoyed this and you want notifications of when I'm going live, please follow. Otherwise, I'm on Twitter and I'm archiving these videos to YouTube as well. So you can go watch them as well. Thank you everybody for stopping by. Also, thank you Katali and Miguel and for coming back after all this time. So if you have any feedback, you can leave them in the comments for the video, or just send a tweet out. That being said, I've run out of things to say. So with that, I'll put on the thanks for watching scene, and I'll see you all on Friday, I believe. Have a great day.